Hi and welcome to video 2 for section 1.6. Again, section 1.6 is our word problems. In this video we're looking at a specific type of problem which is known as a work time problem. So in this type of problem we're going to be looking at scenarios where, let's say I can paint a room in 3 hours and my friend can paint the room in 4 hours. How long would it take us to paint the room if we were working together? Those kind of problems. It could be 2 people, it could be 3, it could be 4, doesn't matter. With these problems, I'm going to give you the formula you can use to set up these problems 100% of the time. And then it's just a matter of getting the information out of the problem and filling in what you need. So the formula we're going to use is this: 1 over the rate of our first worker. Could be an individual, it could be a person. We're looking at an example, it could be a pump. So if a pump is working to empty water, how fast is the pump working? It could be, what else? Anything, a machine that's doing some work, if it's printing off labels, so if it can print off a certain number of labels in a certain amount of time, that's our rate, rate 1, times the time being worked, plus 1 over rate 2, times the time being worked. And this could keep going. If I had 4 pumps doing a job, rate 1, rate 2, rate 3, rate 4 times the time. But usually we're only talking about 2 individuals or 2 pumps. So I'm just going to set it up as 2 for now. But you could do this as many times as you need. And this equals the number of jobs being done. This is usually 1. So the example I gave you, if I can paint a room in 3 hours, my friend can paint it in 4, how long does it take to paint 1 room? How many jobs? 1 job, 1 room. If the problem said how long does it take to paint 5 rooms, this would be 5. 5 jobs, 5 rooms being done. But again, it'll typically just be 1. Filling a pool, painting a room, mowing a lawn, whatever it might be, 1 job. So let's look at an example. And again, once I get done writing, feel free to pause and catch up with the writing if you need to before we get working. So we have the water level in a reservoir must be lowered by 1 foot. Spillway A does this in 4 hours. Spillway B does this in 6 hours. How long will it take if both are opened? So, a couple things before we even get to working this problem. And again, if you need to pause, go ahead and pause to get caught up. One of the issues when I write this problem out that always pops in my head right away is this idea of spillway A, spillway B. Excuse my French, but what the hell are they talking about, right? What is a spillway? Well, in southern Nevada, we kind of know what a spillway is if we've ever been out to Hoover Dam. It's the big sort of towers on the side of the dam where, although we don't have that issue now, but if the water ever gets too high, they can open, they don't want the water coming over the top of the dam. So they have these spillways on the side where they can open them up and it allows the water to drain from the lake. I would say maybe almost everybody watching this video, maybe you've never even heard of something called a spillway. And so that creates an issue all by itself. And if I ever give you a problem, if there's ever an example or a problem in the homework, or more importantly, an example or a question on the exam, please don't get confused by the terminology. Raise your hand and say, what the heck is a spillway? So I always try to write the exams to avoid this confusion, but if it does come up, make sure you ask. So anyways, that's what's going on here, is we got these spillways that's going to drain the water out. One of it does it in 4 hours, one of it does it in 6. How long is it going to take if both are opened? Now, the nice thing about these work time problems is that before I even start, I can kind of get an idea in my head what the answer should be. So if just A is opened up, so let me draw a really poor picture here. So here's spillway A, here's spillway B. If they open A all by itself, in 4 hours, the water level is going to come down in 1 foot. If just B by itself, if they only open B, left A closed, in 6 hours, again, the reservoir is going to drain 1 foot. So before I start this problem, I know my answer has to be what? Less than 4, between 4 and 6, or more than 6. Well, I know if A does it all by itself, it's only going to take 4 hours. So if they're working together, it has to take less than 4 hours, right? Let's go back to the painting example. If it takes me 3 hours and my friend 4, well, if we're working together, we better get it done in less than 3 hours, because I could do it in 3 hours by myself. So if I have a little bit of help, it should go quicker than 3 hours. Same idea. So when I get an answer, it better be less than 4, or I know I kind of goofed something up. Now, what's being asked here? Like I told you from video 1, let's define our variables. How long will it take our both are opened? So that's our variable. So let's call that T for time. And if you can sort of use the letters of the variable, so we're looking for time, so I'm going to call it T. But you could call it X, you could call it Y, you could call it A, B, whatever you're comfortable with. I just call it T because we're looking for the time. Now I'm going to use this green equation to set up what I'm going to try to solve. So I have what? 1 over the rate of 1. Well, what's the rate of 1? It's 4. It takes 4 hours to drain by itself, so that's 4 times the time, T, plus 1 over rate 2. Well, rate 2 is 6 hours times T equals the number of jobs. Well, how many reservoirs am I draining? Just 1. So that becomes a 1. There it is. I have my equation. I have everything I need. 1 equation, 1 unknown, my variable T. Now I need to use some algebra to solve this. I'm going to rewrite this to make it look a little cleaner. If I have 1/4 times T, this is like T over 1. So with our fraction math, this is what? This is really like T over 4 plus T over 6 equals 1. I write it like this, why? Well, because if you remember when we were talking about solving rational equations, I can multiply by the LCD. So my LCD in this case is what? It would be 12. So if we go back to our prime factorization, 4 is the same as 2 times 2 in terms of prime numbers. 6 is 2 times 3 in terms of prime numbers. So the LCD, well, how many 2's do I have? I have 2 of them here, 1 of them here, so I need 2 of them in my LCD. No 3's here, 1 3 here, so I needed that 1 3 here. 2 times 2 is 4, times 3 is 12. That gives me my LCD. So multiply every piece by 12 and that'll get rid of my fractions. I don't like doing fraction math. This is a way to get rid of it. So here the 4 and the 12 cancel out, leave me 3, so I get 3t. The 6 and the 12 cancel out, give me 2, so 2 times t is 2t. Don't forget the other side, 12 times 1 is 12. Now it's a real straightforward problem, right? 3t plus 2t is 5t is equal to 12. Divide both sides by 5. T, the amount of time it would take to drain this if they're both open, is 12/5 hours, which is how much? If I change this to a mixed number, 2 2/5 hours, which makes sense because it's less than 4, so at least logically, I think I have the right answer because it's less than 4, which I expected it to be. So that's it. That's your work time problem. You will always use this formula, plug in the information you know. Maybe sometimes it'll say spillway A does it in 4 hours. We don't know how fast spillway B is going, but it takes 3 hours if they're both working together. So then what we don't know is rate 2. So then we just have an equation we're solving for rate 2, and so on and so forth. But this equation will always work. We're always going to be missing one piece of information, either the rate, one of the rates, or the time, and then it's just a matter of fill in the information and solve the problem. So come on back. We're going to look at video 3, which is going to be our proportion problems.